Hey everyone, welcome back to math class. Today we are going to be talking about simulations. Okay, so if you want to follow along with me, I am on page 742 of our math textbook. So, what are simulations? A simulation is an experiment that's designed to model the action in a given situation. One way of thinking about this is that when you look at probability, we've talked about several different types of probability. A simulation is putting the probability in practice and actually using our probability. Okay? So if you have your coin, flipping the coin has a 1 out of 2 probability, right? But we would have to maybe think of like a scenario where I get three heads in a row, right? That's a 1 out of 8 probability. But, if I flip it 3 times, I may not get heads, right? So I can make simulations to tell me how many possible outcomes they're going to be. So let's keep going on. For example, you use a random number generator to simulate rolling a number cube. If you go online, you type in randomlist.org, that's a perfect example of that. Simulations often use models to act out an event that would be impractical to perform. So, for example, if we wanted to make a simulation of everybody in our class drawing one of 6 types of colors, right? Where they have 6 choices for a color, and we want to draw them out. Especially right now, since we're all at our houses, it'd be impractical, right? But we can actually make a simulation of that to see what are the odds. How many times would it take for us to all get different types of colors? So let's look at number 1. A cereal company is placing one of 8 different trading cards in its boxes of cereal. If each card is equally likely to appear in a box of cereal, describe a model that could be used to simulate the card you would find in 15 boxes of cereal. Now, here's something that's really important for us today. We are not necessarily going to find, for instance, a complete answer in these problems. Instead, what we're looking at is what sort of method would you use to figure this out? Now, let's look at some key things. This is where we have to kind of take the problem and highlight the portions that really help us out. So, for instance, a cereal company is placing one of 8 different trading cards in its boxes of cereal. So we're looking for a probability of 1 out of 8, right? Another thing is that how many simulated cards you would find in 15 boxes. Well, is there anything that we've worked with in these last couple lessons that talks about a 1 out of 8 probability? In fact, I just said it, didn't I? It's a coin, right? I flip a coin 3 times. That's a 1 out of 8 probability. So a method that we could use is tossing a coin 3 times. And each outcome represents a different card. So, for example, the outcome of all 3 coins landing heads up could simulate finding card number 1. You toss 3 coins to simulate the cards that might be in 15 boxes. How many times will we do this? Well, how many boxes are there? There's 15. So we would flip, 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 and that's 1. Flip, 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 that's 2. Flip, 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 that's 3. And we would list out the different times. That's kind of the idea. It's not necessarily us having to do the flipping, but we could chart out. If you look down underneath number 1, they have a chart showing us the different types of outcomes of the simulation. So, for example, 3 heads in a row is simulation number 1. So let's kind of look at this in a practical purpose. We'll look at letter A on page 742. If you want to pause this and do it yourself, feel free. If not, if you want to watch with me, we can. Letter A says a restaurant is giving away one of 5 different toys with its children's meals. If the toys are given out randomly, describe a model that can be used to simulate which toys would be given with 6 children's meals. Okay. So the first thing we have to think about is, what's the probability that we're working with? It's 1 out of 5. And there are several different ways you can simulate 1 out of 5, but a real simple way is creating a spinner. Okay, so if you had a spinner from, and we're just going to pretend that these are all equal parts, right? We have our spinner, and with 5 sections, right? So the first part of our answer is we make a spinner with 5 equal sections, right? How many times would we spin the spinner? If you said 6, you're right. Okay, we would spin 6 times. Okay? All right. So hopefully you guys got that, where we make a 5-sided spinner and spin it 6 times. Let's look at number 2 then. Every student who volunteers at the concession stand during basketball games will receive a free school t-shirt. The t-shirts come in 3 different designs. Design a simulation that can be used to model this situation. Use your simulation to find how many times a student must volunteer in order to get all 3 t-shirts. Now, here's something that's really interesting. Let's say we spin the spinner once. 1 out of 3 probability, right? We spin it twice, another 1 out of 3, 1 out of 3. We would most likely need more than 3 spins, wouldn't we? Because it wouldn't always run on a different color each time. So what they're showing us is that based on the simulation, a student should volunteer 4 times in order to get all 3 t-shirts. If you look at that number 2, the main point we should take from that example is that sometimes you have to go more than however many times there are. Okay? Let's look at letter B and see if you can do this by yourself. Pause this video and see if you can do B by yourself. Mr. Chen must wear a dress shirt and a tie to work. Each day, he picks one of his 6 ties at random. Design a simulation that can be used to model this situation. Use your simulation to find how many days Mr. Chen must work in order to wear all of his ties. What is the probability? 1 out of 6, right? What is something that we've used in our class that has a probability of 1 out of 6? A dice, right? A number cube. And so we would repeat the simulation until all possible ties are selected. So that's where we would actually get our own little dice and we'd roll it and we'd say, okay, I got a 1. So that's tie number 1. Roll it again. I got a 3. That's tie number 3. And I just see how many times would I need until I used all 6. Okay? Very good. So if you turn to page 742, what I want you guys to do, this is going to be a little short video because simulations, they're not going to be our main focus of this chapter, okay? And what I'd like you guys to do, go ahead and look at number 3 with me. There's a 60% chance of rain for each of the next 2 days. Describe a method you could use to find the experimental probability of having rain on both of the next 2 days. 60% chance of rain. So, we could have a spinner, or we could have like a bag of marbles with like 3 red and 2 blue, and we say that red is rain and blue is not rain. I think we should have that backwards, but anyway, so we could say 60% is rain, 40% is no rain, and you randomly pick 1 marble to simulate the first day, replace the marble, and pick again to simulate, right? So it's all about finding aspects that have probability. So you can use spinners, you can use dice cubes, you can use coins, you can use a bag of marbles, okay? You can have, like a deck of cards, okay? So what I want you guys to do, I want you guys to be a little creative with this and look at letter C and comment below with your answer to letter C. During the regular season, Jason made 80% of his free throws. Describe an experiment to find the experimental probability of Jason making his next 2 free throws. Okay, so what is the probability of him making his next free throw if he shot 80%? One suggestion I'll give you is what fraction can we turn 80% into? Okay, all right. Comment below with your answer, and I'll see you guys soon. Bye-bye.